Okay, in this lesson, we're going to look at arithmetic sequences. And yes, it's arithmetic, not arithmetic, arithmetic. And you already have your essential question right here. Your topic is arithmetic sequences, so you don't necessarily have to rewrite it. And so the first thing I want to talk about, because we haven't really talked about it yet, is what is an arithmetic sequence? Well, an arithmetic sequence is basically a sequence, a set of numbers, a sequence that has an adding or subtracting pattern. It has a common difference and that is adding or subtracting. A sequence that has an adding or subtracting pattern. So for example, an example of an arithmetic sequence might be 8, 12, 16, 20. Okay, and so you could easily see here that the pattern is that we are adding 4. That's not the rule. This is actually called the common difference. The 4 is called the common difference, and then we use the common difference to actually write our rules. Okay. Notice that your rule could be a subtracting. So for example, I could have 18, 12, 6, 0. I hope I did that right. And you'll see that the pattern here, we're subtracting 6 every time. So the common difference is -6. Whoops, I just dropped my pen. Okay, so we're going to learn how to write the rules for arithmetic sequences in 2 different ways. And so the first rule that we're looking at is the explicit formula. And it's more like a regular equation where we can do things with it. This is the explicit formula right here. A sub n equals a sub 1 plus n minus 1 times d. I think it's probably more comfortable for you to see the d in front, but you could see it both ways, and so I just want to show that. You're probably thinking, what in the world do these things mean? A sub n represents the nth term. Any term that I'm looking for, any term in the sequence is what's represented by a sub n. A sub 1 represents the first term in the sequence. So if we look at the 2 sequences that we had, 8 is the first term, 12 is the second term, 16 is the third term, and so forth. The n represents the position number. So if I was looking for, say, the 23rd term, I would replace n with 23. And then d represents the common difference. So like in that first sequence that I just labeled with 1, 2, 3, the common difference was 4. So really, it's as simple as knowing these different variables and plugging them into the equation. So the next example, it wants us to determine if the following sequence is arithmetic. If it is, write a rule using the explicit formula. So the first thing we need to determine is what is the pattern. Okay, the pattern is that we are adding 2 every time. So because it's an adding pattern, because we're adding the exact same thing every time, then it is an arithmetic sequence. Okay, so now we can write the rule. So we would say a sub n, so it's just like saying y or something. A sub n equals, okay, so we have to put the first term was 3, plus, now we can put the common difference in the back or we can put it in the front of the parentheses. I'm going to go ahead and put it in the front because I think that's more comfortable. The common difference was 2 times n minus 1. So this would be filling in the explicit formula. But what I want to point out is that you could actually see this final answer in 2 different ways. This is an example of a function rule. This is a function rule for our sequence. But, you know, we're used to seeing rules simplified. And so what I would suggest is that we could now actually simplify this so that our function rule read a sub n equals 2n plus 1. And so it's really important for you to realize that this explicit formula filled in represents the rule for the sequence, the explicit rule, the function rule. And so does this, and you can see it in both ways. And so I would want you to practice being able to write it as the explicit formula and then to simplify it into simplest form. And notice this looks like slope-intercept form. And so that's very relevant for what we talk about in the future. Okay, so let's look at the next one. It says, given the explicit formula, find the first 5 terms and the term named in the problem. So see, here we have the explicit formula. It's just in its simplest form. So if I want to find the first 5 terms, then we just start by plugging in 1 for n for the first term. So 3 times 1 plus 16 is 19. So we have 19. And then we have the second term, 3 times 2 plus 16 is 22. 3 times 3 plus 16 is 25. Now you should start to see a pattern. So I could even go ahead and list it because you should see that we're adding 3 every time. So those would be the first 5 terms. And now if I wanted to find a sub 24, just wherever we see an n, we plug in a 24. So a sub 24 equals 3 times 24 plus 16. And you should get that that comes out to 88. Okay. Okay, so here's another one. It says, given the first term and the common difference, find the first 5 terms and the explicit formula. Okay, so instead of giving it to you as a sequence, like we did the example up here, I've told you what the first term is. So we would say a sub n equals the first term, which is -3, plus, again, I think it's more comfortable to put the common difference in front, but notice it could be in the back. So our common difference was -5 times n minus 1. Now some of you may be realizing that we could have just written minus right here instead of plus a negative, but I didn't want to throw you from the formula. This might be a perfectly acceptable answer, or we could take it and write it in simplest form. So -5n plus 5, and we get a sub n, and I'm going to put the n first, -5n plus 2. So now it says to find the first 5 terms, and so I want you to try use your formula now, your rule, your function rule, and find the first 5 terms. And that will be your entrance ticket tomorrow.